All right, go ahead.
Well, welcome to the November 17th, 2020 session of Tangerine SDR and HamSci Personal Space Weather Station Development. My name is Dave, KV0S, and this week, well, I've been busy doing a lot of other stuff. My wife's had a few health problems, so I've been helping her with those. And uh, that we're getting down to the last week of class, our university decided to send everybody home at the end of this week. So, and not come back till January. So, uh, that's, and that was not expected. We were planning to run the whole thing. So, we are going to do virtual stuff to finish out the classes or the tests or whatever. So, we'll see how that works. So that was that. And I do have a paper due at the end of the month. So I have to start putting more effort into that. It's, it's 85 to 90% written. So I've got a discussion to write. So anyway, uh, not as much radio as I had hoped. I have been doing a little programming, but not, I got stuck and it's always a problem to get out of a stuck programming hole.
Mhm.
So let's see. I'll pull up the list so that I can go in order. And next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going fine here in Scranton. We are also in our last week of classes, so I only have one more day of actually teaching class, and that's Wednesday. And then Scranton decided that they actually planned to send everyone home before Thanksgiving, and so they actually planned to have final exams done before Thanksgiving. So so in just a few short days, so let's see. So we've got our finals. Let's see, they basically start on Friday. I have my American AGU posters are due on Friday. I'm giving a talk at the Radio Club of America Symposium Saturday morning. I am doing moderating Saturday afternoon. I'm the keynote speaker Saturday night. I still have to write my poster for AGU and my keynote speech, which I got some nice input in today. But some good success, I was saying before, we actually are, um, let's see, we
Oh,
actually
you're,
are collecting ionograms here at my house using Edison 200. So here is a sample chirp ionogram, and you can see reflections coming off of about 600 kilometers. Uh, it's hard. I can't say this is altitude, but some distance away, and you see multiple hops here.
Outstanding.
So I have a whole slew of these. Yuha has been working with Dev and me to get this running, and say we ran this last Friday night, and in about 12 hours we collected about 250, 300 of these ionograms.
oh,
So now we have all of this information. There's still some debugging to do with the computer, um, but there's a lot of stuff to work with now, which is good. I think Dev's working on a poster on this. From the personal space weather station perspective, I guess a big question is going to be, how do we actually make this work with the personal space weather station? Because the system's rather data and memory intensive. So if we were to actually make it a standard sounding mode as part of the personal space weather station system, it would we probably have to do some sort of optimization or do some stuff on the FPGA. If we pretend that the Tangerine SDR is basically an EDIS receiver and we just plug it straight in and turn it on fire hose mode into a decent computer that is set up specifically to do this job, it'll probably work just fine. But for now, we're at least doing this, and then we can try and explore those different options. So
very good. I have a question. Are the dark streaks a specific pattern or is it the signal that happens to be coming in at that time?
when you say that these streaks here,
the dark strip, well, you see them all the way across the, are those regular terrestrial signals that are being filtered out?
These black ones,
Yes.
I don't know. I don't know enough about the algorithm
Okay.
to be sure. I also do know that there is some packet dropping going on, and
Okay.
Yuha said that can cause some of this vertical striping that we
Yep.
see. So that's a possibility too. There's a lot of stuff about this I don't know or don't understand.
Well, that's great because
Yeah,
now
the
you
one,
have, you
Nathaniel,
can,
if I could ask, why is the range jumping around, including sometimes giving you negative on the scale?
I don't know why it sometimes gives us negative on the scale. The range is jumping around because Yuha's code is set to automatically search for different sounders from a variety of different distances. So when it finds something and it says this is a particular sounding, it will do an auto scaling of it. And so we're not looking at just a single ionosonde here. We're looking at ones like this one might be the one in Virginia. We think the one it's the strongest and it typically has a slant range of say 600 kilometers altitude for that minimum range. Whereas some of these other ones, maybe this one is Texas or Puerto Rico. So this one has a, you know, 2,600 kilometer minimum range here. So I think we're seeing these different scalings because we're hearing different ionosons.
very good.
Yeah, very interesting.
Yeah,
So can I go ahead?
sure.
Okay. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to the net. I've been pretty busy here. Did some work on designing the detail work for Firehose L mode, which is Firehose Local, which is with that mode, you configure a channel, which means you tell it the center frequency and the data rate you want. And then for Firehose L mode, you tell it the IP address and port of the server that should receive the data. Then when you tell that channel to start collecting data, it will, the data engine will start sending data directly to that server at that IP at that port without the local host being involved. So you can handle much wider bandwidth. So I still need to develop a little simple routine that will run on a virtual server that I have so that I can test that. Another interesting thing that happened last week, I've been participating in the Moderna phase 3 clinical trials for their vaccine. And as you might have noticed, it was announced today that they've discovered that that vaccine is 94.6% effective. So maybe I'm vaccinated against COVID. We don't know. I know I had a little bit of one day of what I thought might have been side effects after the first shot, but no side effects at all after the second. So anyway, they won't tell you until after approval. So we'll find out on that, I guess. I found out also I need to have cataract surgery. So we're going to, I can barely see out my right eye. It looks like looking through wax paper. So it makes it hard to code when you got that going on one side of your brain.
You're
So
in good company.
probably going to try and get that scheduled for next month. They say it's fairly straightforward. Also, Nathaniel, for you, I have a first draft of the step one pre-proposal for the NASA work, and I'm going to proof that again tomorrow morning. And then, no, I don't know whether I need to. I don't need to rush it because you got so much going on between now and the weekend. You won't have time to look at it anyway. But unless you
Yeah.
say you want it,
No, if you could hold it till Monday, that would be great.
yeah, I'll just hang on. That'll give me a chance to maybe edit it down a little bit because I know that you want to include some references,
Mm-hmm.
and all of that apparently has to go into the 4,000 characters that we're allowed. So I don't know how. What we're going to want to do is just include a couple of references because otherwise you're going to run out of space. You got 4,000 characters, including spaces to work with.
Okay.
So anyway, but you said I think you wanted to get a preprint out or get something submitted on one of your analyses so we could mention that. But you
Yeah,
won't
that
have
would
time
be
to do
cool.
that in the next week or two anyway. So anyway, I will get this. I'll edit it down a little bit further. I'll get Dr. Atkinson to review it, see if he has any feedback. He generally does it because this is really not his area of expertise.
Mhm.
The databases and all that other stuff is. So
Yeah.
but anyway, I'll at least run it by him as a courtesy. So anyway,
That'd be good because I do hope I can get this funding because I would really like to see that database come back up. And I have funding for half of a master's student right now. I'd really
Yeah.
like to fund the other half of a master's student too.
yeah.
They don't come in halves, do they?
Yeah,
Well,
I'm hoping, or I'm at least hoping I get the top half with the brain.
Like the
That's
old
the
story about the
challenge.
quarter horse. What do you do with a quarter horse? But yeah, I think when I look at what this NOFO is looking for
Mhm.
and what we're talking about doing here, it seems like a really good fit.
Yeah.
So I don't know if you've got this wired. Don't admit it if you do, but if you've talked to somebody and that's good because it looks like it's a good fit for what they're asking for. So
Yeah.
don't admit it if you have. You're not supposed to admit it. Yeah, we used to have. I used to do a lot of military contracting, and
Yeah.
sometimes they would wire things for the
Well,
university.
I can tell you honestly, this one is not wired. This one's just a fortuitous conjunction. So,
Well, yeah, but that's even better. So
So-
anyway,
Can we go
So-
down the list now?
yeah, back to net.
Okay. Next on the list, we have Dave, KD0 EAG. Go ahead, Dave.
Hello. Yes. Well, I've succeeded in getting some holes dug and to put some sensors in the ground for a little more testing. Now I just have to get the sensors themselves and get them packaged up and the tests started. But I had to get somebody to come dig some holes for me. Other than that, I've been doing a little, and after we have the sensors in hand, I'll have to adjust the code so that it, takes into account any behavior, the behavior of the sensors that's different than what the code we have is written for. And other than that, well, I don't know if I did much. Not so much.
Dave should say that he has not much soil to bedrock in his yard.
Yeah,
He had trouble getting below 18 inches.
oh boy.
yeah. In fact, I think I'm going to have to backfill a bit to get much higher than that. But all in all, I think that should be useful. Anyway, that's it. Over.
Okay. Next on the list, we have Dave McGaw, N1 HAC. Go ahead.
Good evening, everyone. And I will say, if I start putting magnetometers in the ground, I'm going to have the same problem. I think you could classify our part of New Hampshire as part of Vermont. I don't know if anyone's heard the Vermont version of Genesis, but in 6 days, God created the universe, and on the 7th day, he threw rocks at Vermont.
Oh,
But yeah, I'm pretty close
That-
to bedrock myself.
is
But
that a New Hampshire joke?
well, one of the things that also is said is a lot of people like to say that God lives in Vermont. And I say, yeah, he may live in Vermont, but he works in New Hampshire.
I thought that was what they said about Scranton. You go to the worst place you can imagine and keep going another half hour and you're in Scranton.
Possibly.
That's supposedly what Biden said, but I think they're trying to put words in his mouth since he's from there.
It's
Mhm.
possible.
I think
I think
God
that
is.
was a Saturday Night Live skit.
Yeah.
Oh yeah, Well, you probably got us working in New Hampshire. It could be for tax reasons, but
Well, that's exactly it. Yeah, except that
No,
I've often worked in Vermont and then worked in Massachusetts, lived in New Hampshire, and we don't get credit for, I mean, we have to pay their taxes without representation because we don't have a
New Hampshire. It's
tax
because there's
here.
so many people willing to die, because it doesn't say live free or die. So I mean, there must
Well,
be a whole bunch of people there willing to take the plunge.
well, some of them live it as live free and die, but
Yeah.
well,
then there's the winter version,
essentially
live, freeze, and die.
So can we get this back to a
But,
radio
yeah,
topic?
but anyway, I did have one thing I wanted to mention. I noticed that the new magnetometers have been shipped out, and I'm looking forward to working with that. The prototypes, the older prototypes, are format compatible with the new ones, correct? We can plug one on to the other.
The 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 input is presumably yes. I mean the essentially the I squared
Yeah.
C stream, but the addresses and how that works, I'm just not clear on how that all is even.
Well, I think
been
Scotty
made to
left a
work.
pretty we can set it. But the point that I'm trying
I
to
wasn't
make
clear
is
on
that
that.
you were worried about the size of the new one to get it down in a tube. We could use one of the old ones that's a much easier format,
Yeah.
size, form factor too.
And
Yeah.
I think
Very.
Dave is going to test an old one and a new one together. I mean, next to each other.
Yeah, and I
Yeah.
certainly will be
Yeah.
able to. So.
Dave, what are the two addresses you use for the on the remote end? Do you remember?
On the remote end,
On the far end, yeah.
yeah. Well, the magnetometer's at 20, and the temperature sensor, if it's used, is I believe 19.
Okay, so if you do that, then it'll work with the new one, because my addresses are 18 for the local and 22 and 23 for the remote. So I don't think they overlap at all. So you
Dave?
can
Right.
catch any
I've
way you-
just
Plus, there's
Julius?
ability to strap them on the older circuit board.
there
as
is on
well.
the older ones, but not on the newer ones, unless you add a jumper. So
On the
But
older
the old
circuit,
ones, you can
yeah.
you have full control if you cut a few jumps.
Julius is trying to say something here. Go ahead,
Yeah,
Julius.
on the older circuit boards at the 0.0.10, which I got from David, I'm using, as it came through, the local was 18 for the temperature sensor and the remote was 19 and the mag was 20. What I've done is set up two of those boards at the remote end that have actually now let me put in two mags about 6 inches apart. And the address, I strapped one of the mag pins, pin 4, which sets the least significant bit on the I2C address. I set that as a 1, so now I have the temperatures, there are two temperature sensors down there, 18, 19, the mag is 20, and the second mag is 21. So the way I have it set up right now, I go 18, 19, 20, and 21.
okay.
So
Did
that
you-
was all I wanted to bring up. That I thought that we can strap them as we will, and they are.
Yeah, I think
can be
with the new ones,
cross-compatible
you're
if you
gonna
want
have-
something a smaller form factor.
You'll have
And
18.
other than that, I've been working on our MF systems this week. So back
Very
to that.
good. Well, next on the list is Julius. Go ahead, Julius.
Okay, thanks. I managed to get two holes down to about 28 inches, and that's kind of the limit of my auger, and also about as far as I could push my arm down up to the shoulder to pull out any rocks that the auger wouldn't do. I'm not down to bedrock, but the soil in the area, and the two new areas I've looked at, is a little moist down there, but it's not wet. In the wooded area I was originally in, the soil was dry. I don't expect that to be a problem. They're closer to the house, so I can get within 100 feet now of both of those holes. I will use the original buried mag that I made in one of the holes, and I will use the dual mag that I just made, which I still have to put into a tube, in the second hole, and we'll be able to run both of those two separate cables up to the house so I can compare those two setups, one with two mags in exactly the same location, exactly the same physical environment, and the other one about 50 feet away. And that's pretty much it for here at the moment.
Very good. I will say, Julius is by far our most diligent magnetometer tester. So good job.
Been great.
Next on the list, we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, well, as most of you who are getting magnetometers saw, this week I completed the testing on all the magnetometers. I had one board that had a short on it, a solder short, which I cleared that. So now I had all the boards working.
Why
So
was it short?
the short was between two pins on the transceiver chip, on the extended
Yeah.
chip.
Yeah.
Surprise.
And it was an SDA to the enable, so it basically made nothing work on that board at all.
Yeah. Surprise, surprise.
Surprise.
Yeah.
So once I cleared that, then the last board worked. So we got all the sets working. I tested, I programmed all the proms on all of them, and tested all of them in remote and local, packaged them up in 14 sets that were shipped out this afternoon, and I sent those recipients tracking numbers. They're USPS, so they're probably not much good tracking numbers, but whatever. They were shipped first class, so they should get there in a couple days. And that's pretty much it for this week. That was a fun job.
Back to the days of testing.
Back to the days of testing.
Yes.
And taking over a room with setting a table up with rows and rows of them and just going through one at a time. And it was amazing too. It was, I think, maybe the fourth from the last one that had the short. Because everything was going real smooth and just passing, and you're thinking, this is going to be a boring day. Nothing's going to be wrong. Everything's going to work. You're just going to plug them in, and they're all going to work. And and this one didn't work.
Yes.
So it was fun. The short was pretty obvious. So.
Okay. Well, next on the list we have Gary, AF8A. Go ahead.
Yeah, good evening, everyone. I missed a couple of weeks, so if this question's been posed and answered, my apologies. But I know there was a fair amount of discussion a couple of months ago about checking the calibration, I guess you'd say, of the magnetometer boards against Jenny Jump or other known sources. Is that something that still has to happen in the future? That's it. Back to net.
Dave, do you want to answer that, or Jules?
Why don't perhaps Jules would give his.
Okay. Yeah, what I've been doing with my tests up here, I've found that the magnetometer station in Fredericksburg, Virginia is actually quite close, very close to what I'm seeing here, very, very close actually. So I've been using that as my test. However, Heilman wants to do a dual test at Jenny Jump, and I'm trying to help him get set up for that day. So is Dave. That will be a direct comparison between his local magnetometer and the RM3100. So that test is still to be done. If there's anybody else that's close to another station on the Intermag system, that would be handy. But yeah, the Jenny Jump test is still scheduled to be done at some point.
Very good. Is that it, Gary?
That's it. Thank you.
Okay. Next on the list is James, KG4DSG. Go ahead.
Good evening, all. I'm just in here listening, monitoring, and with that, back to the net.
Fine business. And next on the list is Jim, 7J1AJH. Go ahead, Jim.
Hi, good morning. Nothing new. I was just curious what was going on here. These normally happen in the middle of the morning, so I thought I'd drop in and see what was going on. Thanks.
Well, you're welcome. And if you find it interesting, please come back. Next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have I didn't get much accomplished in terms of the project. I'm also very busy with school, like Nathaniel said. Wednesday is the last official day of class. Thursday is a day off, and Friday begins the final exams, which also end the following Wednesday. So it's getting very close. And then that's it for me. I'm no longer a student. I finally graduated. At least
Yay.
that's the hope, anyway. But Nathaniel had the evaluation board ordered for the ADD converter, the 6140. It came in. I just have to pick it up. I am looking into getting this working as a sound card on the Raspberry Pi initially. So I'm going to have to get a Raspberry Pi and SD card. I'm open to suggestions for a Raspberry Pi type of case where the top is open, where you could kind of attach wires and hats that don't necessarily fit in a closed case, but the bottom portion of it keeps it from getting shorted out or anything on your bench. So the plan was to get this working as a sound card through the provided Linux driver from TI. Other than that, in terms of worldwide VLF receivers that are available to the or that are available for online streaming, currently with Paul's network, the fellow that's running it, currently down to 5, and right now he only accepts VLF receivers that are GPS timestamped if you want to run a receiver on his network. Wolfgang, the fellow who writes Spectrum Lab, his VLF computer that his receiver was connected to failed, so his receiver is not currently online. That's why that I want, with this project, we could get more receivers online with Paul's network. Other than that, I don't have anything else. Just very busy with schoolwork. Back to the net.
Well, fine business, Jonathan. And next, let me see, would be Walter, K5WH. Go ahead, Walter.
Hey there, guys. Not really anything to add, just dropping in to see what's going on and trying to keep up with all the great stuff you guys are doing.
Well, fine business. And next would be Michael, AAK. Go ahead, Michael.
Thanks, Steve. I inspected the cable that I had for the 100-foot run, and it was only a individually 2-pair shielded data link. So what I've done is ordered some outdoor shielded Cat6, and I should be able to pull that in the conduit and be ready.
Very good.
Thanks very much.
And let's see. I think we're down to Tom. N5EG. Go ahead, Tom.
Oh, good evening, Dave. Good evening, everyone. Had a few emails with John Ackerman about the clock module. He's been running tests on the 3 different receivers, GPS receiver blocks, and he's been testing them with TCXO discipline synthesizer and has some interesting results. He's been sharing that on the TimeNuts mailing list. His results look pretty good. The F9T, the dual channel GPS module, has very good Allen deviation. In fact, it's better than any of the synthesizer outputs. But in his results, he still needs a synthesizer to clean up the phase noise from the 10 meg coming out of the F9T. So his objective of using a GPS with a synthesizer looks like it's starting to bear some good fruit. It looks very encouraging. So he's got a few more prototypes to put together and test, but his current plan is starting to look pretty good. And that's about it. Back to the group.
Fine business. And I believe that's the whole list. I don't think I've missed anybody. So we're open for general discussion. Oh, we
Yes,
missed Martin. Sorry, Martin.
Yes, Martin.
Good evening. Can you hear
Go,
me?
go. Yes, I can hear you. Please go ahead.
Yeah, my name's Martin, the 6 Victor Hotel in Calgary, Alberta. I learned about this project at Hamcation in Florida last year, where I met Scotty, who wanted to recruit me for this project, so I probably turned around and recruited him for my project. Anyway, we ended up not being able to work together, but I'm an FPGA designer. I have been building ASICs and FPGAs for over 30 years. I'm now retired. I'm a software engineer by profession. I have a master's in software engineering, cognizant in many different languages, and ready to help wherever you need some help and need to learn more about the project. That's about it.
Well, I think there's plenty for you to do if you so desire.
Okay.
So,
as long as I'm going to be locked away inside, I might as well do something productive.
Yes. So we're open for general discussion.
I've got a question for Tom. I'm on the TimeNuts email list, but I haven't seen any communications from John. Has that been a side channel?
I don't know. It may be, he may have shared it just with a few folks on TimeNuts. I don't know if he sent it to the list as a whole. He copied me on a couple of emails that he had sent and attached,
I should get him
a zillion graphs.
Yeah, I should get him to get me on the list, whatever it is.
I haven't seen that either.
Yeah,
you might have him send it out to either this list or TimeNuts and just ask who would like to stay abreast of those developments.
Well, we do have a clock module list, which maybe he should copy it on. I'm sure he wants TimeNuts opinions on all of his tests, but
yeah,
David, you're on that list, and I know Tom, you're on it, and there's maybe a couple more who would ask to be on it.
There's a clock module list.
Yeah, there's a clock module list we started a while back, but was specifically for like pre-design questions, running it by a few people who wanted to be associated with it, but it really hasn't seen any use since it was formed. So haven't been any messages on it.
Okay,
maybe
I'll try and forward the couple of recent emails that he had to that clock module list.
Okay. And then
if anyone else is interested,
yeah, and if anyone is interested in the clock module list, drop me a line, or I think John Ackerman is the one who set it up. So you drop him a line; he'll be glad to add you.
Yeah, great, thanks.
I think you're already on it, David, because you had asked earlier.
Yeah, but I haven't seen any of these latest communications, and I am interested to look at it.
Yeah.
Okay.
In fact, some of those are so interesting, they might be well sent to the Tangerine list, just to have everyone look at them, because he's done a lot of work.
Yeah, I have another question back to the magnetometers. I noticed that, I'm being sent one module. So my question about whether the older ones are compatible is...
But one module means a pair, David.
One pair. Oh, okay, very good. But the other question, are these compatible with any Raspberry Pi, or is there a particular platform they have to go on?
Well, I'm using one on Odroid N2, and they're supposed to be compatible with the Pi. although I can't say that I've tested them on a Pi.
Okay, because
They
I
have
have,
been they have been tested on both. Yes.
all right, because I have Raspberry Pi, I have Pi 3s.
They should
I
work.
think that shouldn't be a problem.
Very good.
And in fact, what I'm interested in is when I plug it on the Odroid, apparently the Odroid does not enumerate the way the Raspberry Pi does.
No.
And so I'm interested for those who have real Raspberry Pis, when you plug it on there, go in the enumeration table and look, because you should see tapper,
Yes.
magnetometer, PN 3100. You should see all the whole description and the serial number and the rev and all that, because that's what's in the file that I programmed into the PROM on every board. So I want to make sure that that's, I mean, I can read the PROM out and I can see the data, but I haven't plugged it in any board that actually reads that and enumerates it into a table.
Yep.
Scotty, I
Well,
think
that,
this has
Scotty.
been mentioned before, but just one quick question. Is it possible to accidentally plug the magnetometer connector into the Pi backwards and fry it?
Yes.
Yes, it is. Yes, it is. I know I can tell you from experience that plugging the magnetometer module in backwards does not fry it, because I did that once.
Yeah, same here.
Well, that's what I'm talking about.
But the module, the Jules, the ones that you have don't plug on the Raspberry Pi. That's correct, right?
Well, the one that's correct. But what I've done is I've actually built a Pi hat to use the old 00.10s. So
Okay.
that plugs in, and it also includes a real-time clock that I use with it as well. But yeah, I did the same thing you did, Scotty. I accidentally plugged the module itself in backwards, and it didn't fry it, fortunately.
Yeah, but I have not tried plugging the Pi board in backwards. The
Right.
hat.
So I haven't either.
I think Dave did that once. Dave Witten.
Well, I've done most bad things.
I have been using a Pi hat on the N2 and using a quick connector to talk to the module, but I only have a local module right now. But I've been running it for close to 4 months with no crashes, his software.
Well, it'd be interesting to see, because theoretically the David's modules and the new modules, you can run them interchangeably on each end. They use the same pins in the cable.
Yep.
So
Yeah,
should be no difference.
That's what I was going for. Yeah, I had a mishap, discovered a vulnerability of the magnetometer modules. The Z-axis sticks up, and it got whacked and broken on one of mine.
Ouch.
On the magnetometer. Oh,
yeah, the actual
coil
magnetometer sensor.
Yeah.
Broke. So I'm down one.
Well, I think
mag module.
actually, and if you're going to mix the boards, one thing that you must be careful with is don't put the remote local jumper on the new board, because that hooks the 5-volt line up to one of the interrupt lines, and while it won't hurt the Pi, if the pull down transistor goes on and tries to pull the 5 volts down, it won't be pretty. So you should leave the jumper off if you're going to do that, if you're going to mix them. And there's a remote local jumper on the board, on the new ones.
On the new ones, right? Okay.
So if you're going to use it with an old one, take that jumper off, and you should be okay.
Well, we better make sure that we have some pretty clear instructions on how to put these things together, because we won't engender very much appreciation from our ham radio buddies if they, plug
fry
it
the first
together,
one they
because
get.
It's
Fry
not
'em up,
clear how to
yeah.
put it together, and they fry their $50 module. They won't be happy at all.
This was kind of the reason.
Obviously.
Go ahead, Dave.
Yeah, obviously we have to do the very best we can, but there's nothing that without a shrouded 40-pin connector on the board itself, there's really nothing to prevent people from being off by one, when they plug a hat onto the Pi or something like that, and you can get some interesting motion between voltages and grounds, depending on what else.
Matter. because the 5 volts and 3 volts are at the other end of the connector. And if you turn it around, I don't use those pins, so they would just go nowhere. And the worst that's going to happen is you're going to ground a few pins on the connector that are IOs. So
Yeah.
probably be okay, but I don't know that I'm brave enough to try it with one.
Yeah, well, what I was thinking of more is just inserting the 40-pin connector, putting pin 1 and 2 where pin 3 and 4 should
Right.
go.
Shifting it off
And
by one. Yeah.
Yeah, and that really, all the grounds are then off by 1, and all the and the
And
voltages are.
it puts 5 volts right on one of the I2C pins also, which is not.
Can I make a suggestion here?
Yes.
Yes.
I actually build pie hats, and we just grab one here. Show you one of the ways you can avoid. There's one here. One of the ways you can avoid putting the connector on in the wrong way around is to use some standoffs on either side of it here, which will mate with the holes at the top, which I made in the board.
And we could do that because we have holes there. So we just
and it's virtually impossible to line that up incorrectly because it won't fit. The standoffs are in the way.
Okay, that would
Great
be
idea.
Good insurance.
Good idea.
Same way here as well on the other side. And these are just stock items you can buy from DigiKey.
Sure.
That's my FPGA controller hat, by the way. Repeater controller hat, rather.
Cool.
With an FPGA.
So, okay, so I did not put any standoffs on the boards that were sent out, but that's a good idea. So next round we'll. I still have I have 11 sets left here, so I need to go get some standoffs, and then I can mail them out first class to the people who got the boards, and you can install them yourselves.
I should have plenty of standoffs for mine. I've got big sacks of them.
Okay.
Yeah, same here, Scotty.
So do you have a part?
Me as well. I use those.
Okay. Do you have a part number you can send me? They're I think they're 1/2 inch if I remember right. 12 millimeter or 13 millimeter. I can look it up. I just thought.
Scotty? You want a part number for that standoff?
Yes.
Oh, okay. I'll have to look it up.
All mine I've bought in volume off Alibaba or someplace. So, and they're nylon.
Yeah.
So I've got nylon and aluminum and stainless. And,
well, I bought a little kit that was in a bin that had 10 of each, all different kinds.
Yeah.
But
DigiKey does have them.
That's been so lost in the move 4 months ago that I don't even know where it is anymore.
You can got a bag of them here. Complete with part number.
You want to put it in the chat window?
Could do. Get my other machine going here. Yeah, let me get my other machine going.
Yeah, so of the ones that went out, they went out in pairs. They're all strapped, one for remote, one for local, with the magnetometer board plugged in already. So basically all you really need to do is plug it on the Pi and plug in 100 feet of cable and bury the other one. Bury the remote one. And the remote one obviously is the one that has the Pi, the magnetometer module on it. And if you're curious as to all the straps and jumpers on it, see, you know what? I need to put the latest schematic up, but even the one that's up there is good enough. I'll put the latest one up on the Tangerine site. The schematic has all the strap information on it. Let me see what's actually up there. There's an older version up there, but the newest one needs to be put up there. Yeah, XB1. We're up to XD1, so. But actually, XB1 has a good good explanation of what you're going to see with the I2C addresses and what all the straps do, all the jumpers do.
I'm planning to bury the one I get in a piece of 3-inch PVC, actually, that will have a swimming pool noodle in it for insulation that happens to fit perfectly in 3-inch that I bought at the grocery store. It's a closed cell foam that like kids use to clobber each other in the swimming pool, and it has and it's probably cut it in half and hollow out a spot and put the whole thing in the pipe, and then put caps on either end.
Yeah, 3-inch pipe. You should be able to fit the board sideways in that.
Yeah, there's an excess of room there, but I needed bigger diameter holes to do that.
Yeah.
And it's I had to use a post hole digger instead of a garden auger for that one. But I'm just doing that because I have it ready to go. My other ones I can fit in other smaller existing setups.
So
I'll put some pictures somewhere about it.
You use a cap on the top and the bottom, or you a sweep or a T?
Yeah.
Cat, just a cap?
Probably a cap and a elbow and, something like that.
So then you actually leave it sticking up out of the ground a couple inches, right?
That's the plan. That's what I had seen that Julius had been doing, and mine is much bigger diameter than his, at least for that one. But I could put a step down to smaller, but it starts to get expensive buying all these PVC fittings and lots of things to glue together. I'm not real, so I may keep it simple.
Yeah,
but
Dave?
You can make a pretty good little. Yes.
Yeah, if you just put a right angle fitting at the top and a cap on that, then you'll have room to mount what I did on mine was mount a waterproof Cat 5 connector.
Yep.
In the face of it. And so I can just disconnect the cable anytime I want to. But if you use that right angle, then it makes everything nice.
Yeah. That's really what I was planning to do. I've got, my office is full of PVC pipe of all the descriptions. And the nearest hardware store to me thinks I'm very strange because I come in and make very odd requests. But yeah, it's readily available. It's cheap. You can cut it with a table saw like butter, and it's easy to work with.
Okay, got the number, Martin. So that's 11 millimeters between the boards then, right?
Approximately, yes.
Okay, good.
Do you want the part number for the connector I used too?
The connector, which connector?
40 pin. The one that goes between the hat down onto the pie.
Yeah, does it have long pins?
Long pin. No, these are solder tails.
Okay, but no, I need 10 millimeter pins because we have to have them stick up above the board for it to stack whatever comes up above.
Okay.
Okay, and M2.5 at the top.
Yeah, I see you're using M2.5 hardware. I use 440. It's pretty much the same size.
Well, this is all metric.
So 15 millimeter would be about 3/8. Is that right?
No, 25.4 millimeters to the inch.
Yeah, it's 12.5 to a half inch. Yeah.
And McMaster carries all of the millimeter versions, both nylon and stainless steel and brass.
That's
Yeah.
close to 5/8.
So why do you use a 15 millimeter? Where do you use the 15 millimeter one, and where do you use the 11 millimeter one?
The 15 millimeter one is at the bottom.
Okay, it goes on the bottom to mount to the enclosure or wherever, right?
Goes down to the pie. 15 millimeter one here.
Oh, and then the 11 mounts on the top of the board. Okay.
Hang on.
Yeah, the 11 is, you could probably use 1/2 inch there.
There we go. So long one's at the bottom, and then that
Oh, I
short
see.
one.
Okay, got it.
The
So
short one goes into the longer one, and then the short one it spaces.
right.
And then I can put a screw. I haven't got the screws in this one because I'm working on it. And then the screws go in the top there.
I presume the threads are M2.5 also, right?
Yes, they are.
I mean, the male thread on the, yeah, it is. Okay.
Yeah, you can use a 2.5 millimeter thread on it. I presume there's an imperial equivalent of it somewhere, but tell you the truth, I didn't spend any time looking for it.
Yeah, 4.40,
It's a
4-40.
lot easier to
Yeah, I
stick.
use 440 hardware, and I have a selection of different lengths.
I'm going to use Whitworth threads.
I recently modified a 900 megahertz transceiver to put a BNC bulkhead mount connector in the back of it. And it takes a really odd thread that I had to go buy a tap on eBay to do it. It's a
Yeah.
3/8 32 National Extra Fine.
I got a piece of furniture from my dad. It's an old Herman Miller piece from the 1950s. And it's a fiberglass molded bucket with a metal base, and it's held on with 4 screws. Well, a couple of screws were missing. So I took the screws out, and they were like 3/8 18 or something. I mean, they're standard size screw, but they have a weird thread pitch. And I had a heck of a time finding the screws.
Yeah. I see Nathaniel has Northern Lights. Can you see it from there?
Not usually.
Oh, I can. I just look outside.
I'm in Pennsylvania right now. Yeah, no, I'm not quite up in Calgary.
We haven't had a good display down in the States in a while.
We can all have Northern Lights.
Yeah.
And they're not going on right now where I'm at either.
In Phoenix, no.
I have the equatorial lights going on down here, which is Christmas tree lights on the houses.
The way things are going, you might see. Might be seeing something.
I do have some friends who were up in Calgary for a while studying.
Oh, really?
Oh, yeah.
Did they survive?
Yeah. One of them's a professor at NGIT now. Actually, another one of my colleagues here at Scranton, he did a postdoc up at Calgary.
Oh, yeah?
Yeah, Calgary they've got a decent space physics program up there, too.
Yeah, I think we've got a grad student here at Dartmouth from Calgary.
Oh, really?
Really?
Yeah, Eric Donovan is up at Calgary. He studies the Northern Lights.
I didn't go to the University of Calgary.
No?
No, I grew up in the UK, so I went to school there.
There's quite a few space physics researchers in the UK also.
No. Very good. So, Scotty, what do you need FPGA-wise?
Pardon me?
What do you need done FPGA-wise?
Build a project that will fit this schematic that I'm working on.
Okay.
I'm almost done. I'll send you the schematic when I get it done. Because that's the next thing, is to verify all the pins. You know how it goes. The pins have lots of unique requirements. So the only way really to tell whether it's going to work is to build a project and hook the pins up and verify that Quartus says it's okay. And so that's pretty much the next task on the plate, is to do that
Okay.
and verify that I didn't make any mistakes on connecting the pins up, because I've tried to use it. It says you can use 500. It has 500 IOs, but good luck trying to use all 500 IOs, because you're stuck with bank limitations and IO limitations and pair, differential pair limitations and things like that. So, but I think I got above 480, which is actually pretty good. And whether you can use all of them or not, I don't know. I'm going to try to connect everything up to something and see if Cordis complains to me. And are you running Are you running under Linux or Windows for the FPGA compiler?
Windows.
Because to do this FPGA compile, you have to run under Linux, because it will not compile the memory interface under the latest version under Windows.
Oh, really? Okay, no problem.
And I've got Intel. In fact, I have to try this, because they sent me a patch to version 20.1, and I tried it and the patch didn't work. So they sent me back another sequence of things to try that I haven't done yet, and they claim it will work, because I sent them a copy of my project. So, I mean, it takes them 2 seconds to fire it up and see that it doesn't work. So I don't know why they sent me a patch that they didn't test. But at any rate, so I've got to try that. And if that works, then we can use Windows, which is preferred, because all the schematic stuff is done on Windows. And I prefer not to have to go back and forth between two machines to do it.
I'm surprised, because Cordis is written in Java. So to run on either environment with no issues.
Should, but the trouble is, I think that they have different teams doing updates. And so they get a little excited on the updates and they put stuff in and they don't fully test it. Because I remember if you look on the releases, between 18.1 and 20.1, there are no Windows releases. But if you look on Linux, there's like 4 or 5 releases of Linux. And a lot of them don't work. They just, and Charlie, my business partner, was really amazed, because you download it, you install it, and it won't even launch. It won't even run. Well, my opinion on a lot of the Linux stuff is, if you want the code to work, if you want a piece of a tool to work, start with a blank disk, install their operating system of preference, which is Ubuntu in their case, and don't pick a different version than what they pick, and don't install anything else first. Install their code once, because that's the way they test it. Load Ubuntu, load the code, does it work? Well, as soon as you start loading other apps on there and loading other libraries, you're going to break something, and it's not going to work. So, and this is the problem with my business partner. He likes to load his Linux machine up with everything in the peck in a bushel, everything. And so he gets incompatible versions of packages on his machine, and then things don't work. So I still say, if he had started with a fresh copy of Ubuntu, those Linux versions probably would have worked, because at least, I mean, they must have at least fired them up, right? And see that they launch.
Don't count on it.
When it doesn't even launch at all, that's kind of lame.
Big assumption.
I mean, okay, I get it when it doesn't compile some esoteric RAM in their memory interface. Okay, I can buy that they can't test everything, but come on, guys, you can test the initial launch.
Well, having been around this for about 30 odd years, I have a few tales to tell about tools. But number one, I use Cordis 17.1 at the moment, my Maple Pi project, because it's the most stable release there has been in the last couple of years. Yeah. And number two, if I'm going to do it under Linux, what I usually do is I run a virtual machine under Hyper-V under Windows. And that way you can give it a dedicated machine. Yeah. Be able to start from scratch. I have Ubuntu 18.04 as well I use.
Yeah.
And I find that works really well. And then when you're done with it, you just blow away the virtual machine.
Yeah. Or you keep the virtual machine there forever, because the customer is going to continually want updates and all that.
Just shut it off.
Yeah, because I'm using 17.1 for another project, and it's because that's what we started on, and I'm not upgrading the version to Cordis unless I have to, because as you know, you break lots of things when you do that, especially the IP. That's what I found out, was that the memory IP would compile under 18.1. And now that I'm talking about the memory project that they give you online. Okay, this is their sample project that runs on the board that Dave, you and Dan and I have.
Yes.
And so this is supposed to be a no-brainer, right? Well, I fired up under I think I was using the 18.1. Anyway, and it doesn't work. It will not compile. I'm sorry, it starts under 17.1, it compiles. And then, but I have a problem with it. And the guy said, mainly because I want to use a -6 speed grade part. So he sends me the -6 speed grade update files, but they're compiled for version 20.1. So I said, okay, I don't care. I'm starting this as a new project. We'll go to 20.1. You go to 20.1 and the damn thing won't compile. And it did on 17.1 and it won't. And then they tell me, well, if you go to Linux 20.1, it'll work. So it's
sounds a little.
It's just a nuisance, you know. It's like, get it right, guys. But to be fair, I mean, it is extremely complicated, and I'm sure they've got thousands and thousands and thousands of man hours in this code. It's like Windows, you know. It's like no one person knows how all the pieces work. So it's no wonder they break it. They just don't have very, very good regression testing, or maybe they don't have any regression testing.
Well, ever since Windows 10, my release, the October release 2 years ago, my networking has been broken and they still haven't fixed it yet.
Don't get me started on Windows networking. I bought 3 Dell laptops, all within a few months of each other, and I put them all on my home network, and there's not an instance where they all see each other. Sometimes one sees the other two. They pretty much all see themselves most of the time, but they don't see the other two. And then I'll get on one and it can see that one, but that one can't see that one. You know, A can see B, but B can't see A. What?
I know what you mean.
So then, you know, you go back to
Oh, there you go.
the thumb drive. You know, that's the way you move stuff, but it's a nuisance.
I know, been there, done that.
Yeah. But anyway, so I don't know how I'm going to do this because they told me to get 20.1 working, I have to upgrade, not upgrade. I have to what do you call it on Windows? Update. You have to run Windows Update. And you have to update the build number of your version of Windows. And they said this is a specific version of Windows. It has to be higher compile number than that. Okay, so I updated it to the highest I could, and it said I was all up to date, and it was still not a high enough number. So I had to go stand on my head and do a bunch of things and get to the higher number now. And then I had to load this. They've got a Linux. It's kind of like it's a Linux command shell for Windows. And
the Windows subsystem for Linux.
Yes, but there's 2 versions of it. Yeah. Okay, and it said that you have to have version 2 to run this new patch that we gave you.
Yeah, I think I have both versions installed on my computer.
Well, I have both of them installed, and I went around and around and got to version 2. Now they give me this new patch. They said, oh, by the way, make sure you're running version 1, not version 2. So how do I uninstall that? Do I just go into Windows Components and get rid of it, or I don't know.
Yeah, I was looking. I have both Ubuntu 16.04 and 18.04 running under different versions of Windows subsystem for Linux, and I want to get rid of the older one, but I haven't figured out how, and I haven't had the energy to do it because I've had other things that needed to be solved first.
But it's like this. How would you go from, suppose you installed Ubuntu 18.04. Try going back to 16.04.
Yeah.
You can't do it. You have to start over.
I don't know.
So I don't understand how I'm going to go from Windows build XXX to build.
I currently have 3 computers sitting under this desk. One is running Windows 10. The other one's running Ubuntu 20.04, and the other one's running Ubuntu 18.04.
So see,
you might be able to use System Restore.
You have the risk of breaking a whole bunch of stuff, right? That I loaded between then.
Well, yeah.
They assume that everything's static and that I never loaded any other software between their stupid updates, which is not true. So
I have a question regarding the the Raspberry Pi and the Pi Hat. Now, the Raspberry Pi 4 is known for having its chips run pretty hot. Typically when you buy a Raspberry 4 B plus, it comes with a case and a fan. Now, the magnetometer board, is it going to cover up is it going to be in a place where it doesn't allow heat to escape from the chips on the Raspberry Pi 4, and maybe we're going to have a heat problem with the Raspberry Pi as soon as we put the magnetometer hat on there?
it's possible because the Pi Hat does cover over the processor and the RAM. So
And
do you have a little stick-on heatsink or something for the Pi?
well, they have heat sinks on them already. I mean, and that makes, you know, there's some space required for those as well.
I haven't experienced any you know, any significant amount of heat. I often wonder who it is that is, you know, if there's, I guess you can't overclock them anymore or something, but still, I wonder what folks are doing that generates that much heat. Perhaps, certainly running the software that reads the magnetometer does not generate any significant amount of heat from the CPU, besides just to kind of warm.
So Bill, where does the fan go? How does it blow the air? Down on top or along the surface or what?
Down from the top. The Raspberry Pi, as it comes, it goes in a case, and then obviously you don't have to use the case, but the top of the case has a fan in it blowing air down on the chips. And I think I'm going to have to take the Raspberry Pi, or maybe I just need to buy another Raspberry Pi 4 and start building that in order to be able to work with the magnetometer.
Well, like Dave says, it doesn't really produce much heat. And one of the things that we could do is we could use another connector and raise the magnetometer board up higher to give it some space. But if you're blowing air down on the top of the magnetometer board is only a half of the width of the Pi. But unfortunately, it just covers the CPU from the picture I'm looking at here. So if the fan is right over the CPU, it's going to block the airflow. But if the fan is over the center of the board, you might get some airflow underneath the board across the CPU, especially if you've got a heatsink stuck on it.
Well, I don't know if there's going to be enough clearance to put the magnetometer hat on the Raspberry Pi when the Pi is in a case, though. That's the concern. And I mean, you need the case to hold the fan.
Well, then what you do is, isn't there a hole in the case for the 40-pin connector?
Not in this case. This case that I have does not have that.
Because I've seen some of those cases that have the hole for the connector, and what you'd have to do is you'd have to just use another connector, just a regular connector, no board or anything, to stack to get the board higher to get it outside the case.
Let me show you this case. See?
That's pretty low profile.
Complete. Yeah, there is no hole.
I don't think you're going to plug a Magpie hat on that and get it inside the case.
Right. That's what I'm saying. I don't think you can do that with this particular kit.
Yeah, I have that kind of case too, I think.
But I've seen the
many.
Yeah, but on yours, Dave, does it have a hole in the top for the 40-pin or no?
Actually, no. This everything fits inside, I believe. I haven't tried it with your board, and I don't know if this will be anything I use in the end.
It won't fit inside there.
It probably won't.
It'll be too tall.
It's pretty rare I ever get these to the point where they actually have the lid
I've
on
seen
them.
some plastic cases that are relatively low profile that you could stick just a male-female header on top of the Raspberry Pi, which would extend the pins up another 20 millimeters, and then it would extend the hat up above so it's outside the case. And then you could put a fan, if there's a fan in the case, then that would blow right on the CPU, and the Pi board would be outside. The magnetometer board would be outside.
Well, that may be the thing to do. I think I can probably take the top off this case, then use a Dremel Moto tool to route out a rectangular slot, and then put an extender to bring the pins out of the case.
Yes.
And I mean, Adafruit sells extenders. You could just get another connector, and that will work. You could even plug 2 or 3 of them together. It's all low speed. So, I mean, even if you extend it up an inch above the top, it's not going to make any difference. It just will be mechanically unstable.
Yeah, the only reason I'm concerned about the heat is because, you know, I'm running more than just the magnetometer readers thing in there. That's the entire local host, with all of the FFT stuff going.
But the other thing you might do is, if you were to move the fan from where I saw it in that case, from the center down to where the HDMI connector was, to that edge of the board, that long edge, then the air would hit the main board and flow underneath the Raspberry, or the magnetometer board, and you would get some cooling on the CPU, because we don't need any cooling. So run the air along the top of the Raspberry Pi module. See what I mean? Because we're only a half module, so the lower half of the Raspberry Pi is exposed. So if you blow air on if this is blocked, if you blow air here, it's going to flow up in between the boards.
Well, it would mean making a new case. I have to maybe get with our 3D printer guys and make a new top for because you don't just move where the fan is on the case, because it's got, you know, it's built to hold that fan in the right place, and it's got the holes for the fan and for the air to flow and everything else. So you'd have to design and make a whole new cover for the case, but it could be done. It could be done.
But what you want to do is you want to change the direction of the airflow so that it flows in between the two boards instead of down on the top of the board. Otherwise, it's not, and you won't be able to blow air right on the CPU. So that will be a question: is that going to be enough air if you blow it down? And because every corner it goes around, it reduces the cooling capacity.
Yeah.
Reduces the speed because it increases the back pressure. But
well, it probably would, because I mean, you can run the fan on 2 different speeds. I'm running on a low speed. So if I have an inefficiency introduced into that, I'll just plug the fan into 5 volts and run it at full speed.
Plug it into 12 volts, and it'll run for a short time at really good speed.
Yeah, it'll run for a few. Yeah, then
lift it off the desk.
The levitating Pi.
But you know, I've been thinking about this too. Is we're going to have to come up with a case for this board set, because leaving it lay out on the desk is not going to be a valid solution. So maybe the case includes a new Raspberry Pi. Dave's laughing because he remembers our old.
I have HP SDRs in no case for what's that, 13, 14 years.
Yeah. But so I don't see any problem. I mean, I'd like to come up with a case for it, and you know, maybe we have a side by side that has a Pi case, a space for the Pi and for the Tangerine, or maybe we have 2 separate cases, or maybe they stack, or somehow we do it. But we'd have to work on cooling that way. And I'm kind of thinking I would make the case tall enough to put the fans in the edge and have the air blow across the boards. Because especially if you put one of those stick-on heat sinks with the tabs sticking up, if you could get airflow directly across one of those, you're in. You don't need much air at all.
Well, one question I do have is, in order for the radio portion of our data engine to work, does it need to be shielded in such a way so that it doesn't pick up noise from wherever? I mean, typically you mount a radio in a metal case so that you got a shield around all the electronics. And that way all the hash that's generated by all of the solid state digital processing doesn't get into everything else in your shack. But as of right now, I mean, with the unusual physical layout we have, I don't know how you're going to do this other than 3D print it and then injection mold it, which I don't know how. Then
Well-
there's a way to process to spray aluminum inside of those, I suppose, to make a shield. And now you're getting expensive, right? I mean,
Yeah, I was looking for the, I don't see it on my desk here, the RX888. I mean, that's in the same price class as we're going to be, and it's got a metal enclosure. Now, how do they do that? Do they, I mean, you start doing CNC machined enclosure, you're talking $100 for an enclosure, just for the enclosure. And theirs is all nice and powder coated, and it's a couple pieces with heat sinks stuck on there, screwed on the outside. So that can't, I mean, as far as the cost of the unit, that can't be more than maybe 25 bucks worth of the cost of that $180 unit that I'm buying. So if we can do something like that, and they don't use a fan, they use thermal pads to the metal case.
right?
They conduct the heat out. Whether we could do that or not, I don't know. But I think in the terms of shielding, we're putting the RF modules on the bottom. We're putting the data engine in the middle, and we're deliberately putting layers of copper on the bottom of the data engine of the RF modules and on the bottom of the data engine. So all we're going to have there is grounding layers and bypass caps. So they're effectively between the boards, they're going to be well shielded. If we can put them in an enclosure where we can get some metal contact on at least 2 or 3 sides, I think we could essentially have 2 shielded compartments. And also what we've done is we put a shield and rail on the PC board on the RF module around the RF section, so that we could get a custom RF cover and we can solder it down on the RF module if we need to. We don't have one for the beta tests, but we don't know that we need it yet. But if we do the testing, we find out that we're getting RF, digital RF into the modules, then we may have to put a shield on top of the RF board.
Well, based on past experience, I think shielding is going to be an issue.
But so what do you think about a metal case with basically contacts to the RF module, I mean, to the data engine, and we're basically using the data engine as a shield between the 2 compartments, digital stuff on one side and RF stuff on the other side. And that would preclude putting the Pi in the same enclosure. That'd have to go in a different enclosure.
Unless it's in another block of stuff that's also shielded from everything else. I took a look at how Sony does this because I had to take apart and repair a digital TV, and they've got this clever little technique where they have, it's almost like Scotch tape, except it's copper. It's like copper tape that's adhesive, and they cut it and they stick it down to make a solid shield that runs between their the side of their board and the side of their case. So it's a continuous shield. So
that's
we use that as well, and 3M makes various forms of shielding tape.
And the adhesive is conductive, right? So you
can get conductive or non-conductive.
Mm-hmm.
Yeah, you have to decide
many
what you
different
want.
weights.
Yeah.
So but yeah, I have tape that it's conductive to the extent that when you stick it down, it makes a good RF contact.
Okay, so you can shield a board edge to the case and have a good shield connection.
Correct.
Without a bunch of clips or springs or. Yeah, and I've seen that stuff too. It's just like neoprene bead with woven braid on the outside.
There's that too, but I'm talking about actual copper or aluminum tape with an adhesive on it.
Yeah.
And it will make contact, and
it's just that then you can't
use it for RF shielding.
You can't really disassemble the unit when you do it that way.
Yeah, but you're right. There also is conductive rubber that you can use for connecting boards to cases and things like that. Yeah. And you stick a gasket around, where a top goes on.
But what's going to come up really fast is a requirement for a case. I can see how that, I mean, it didn't really take us by surprise because we knew it was coming in HPSDR. We just ignored it until,
Yes.
until we couldn't anymore.
I'd
Well,
like to ask a question.
Yeah.
Is there a requirement that, excuse me, that the Raspberry Pi and the data engine actually be physically co-located, or can they be physically separated?
They can be separated.
Absolutely.
So maybe separate cases isn't such a bad idea.
In
No,
fact,
no,
you know, maybe
it's
the
workable.
magnetometer would make better sense on top of the data engine instead of on top of the Raspberry Pi from an RF point of view.
Yeah, the only other point, I posted some information on Pi 4 cooling. Side flow air with a small heat sink would probably be sufficient. You wouldn't have to perpendicular to the board. You can go parallel to the board. Some of the graphs in there show the actual throttling of the processor where it actually, you won't hurt it. It just slows down significantly when it gets hot.
Well, one of the reasons we're talking about this is we envision that there will be a few people that just want a magnetometer and they want to run it on something, and it's able to run on a Raspberry Pi or anything that has a Raspberry Pi GPIO.
Well, that shouldn't be a problem.
Hey, Bill, did you look at the second link that that James sent in the group chat?
Oh yeah, there's some wild heat sinks out there.
My kind of cooling for the Raspberry Pi.
Actually, though, one of the ones you might want to take an interesting look at is they built a metal case that actually puts a heat sink down onto the processor. It's part of the case.
Yeah.
Well, it makes physical contact, and the case itself becomes the heat sink.
Have you seen the Fit PC? Have you ever heard of those?
I think it's very similar.
Yeah, it's a CNC machine top, and they have an island that they don't machine, or they don't machine as deep, and then they put a piece of thermal tape, a thermal goo on top of that, and it sits right over the processor and physically touches it and conducts the heat out into the case.
Yeah, I think there's a case in that second article called the Argon Neo. I think that's what they're doing. They've got a heat sink on the inside cover that sits down on top of the processor. No external fan.
$15 for the case? Now I
Well,
want
it's
to know
metal.
what that cost.
Yeah, it's about as much as the Pi. So.
There you go. Yeah, and actually, if you go to the link, it takes you to Amazon, and the bottom picture they actually show you the middle piece that has the cutout island that fits down on the processor.
Yeah. So there are options. It wasn't one of these articles, but one of the ones I read when the Pi 4 came out said, they tried positive pressure, negative pressure, parallel, perpendicular flow. It all boiled down to the fact that you need something. The bare processor is not enough if you're putting it under any load at all. And like I said, it won't hurt it. It just slows it down until it cools off, and then it speeds up again.
Well, Bill sure knows about putting it under load, right, Bill? I mean, that's you give it a good workout.
Well, yeah, it's running. If you're running everything at once, like you're running FT8 and Whisper, and you're running 8 channels of data acquisition, it overall processor reutilization hovers between 30 and 50%, which isn't running it flat out. You're not overclocking it. So I haven't. What I've done is I've had some little monitors that read that, show the CPU temperature from time to time, and it doesn't get close to the throttling point. But on the other hand, I have it in a case with a fan on it. So
yeah. Well, I'm looking at the this Neo case, and it's touting passive cooling, but then it says that it supports a cooling fan, but I don't see any way to hook a cooling fan up to this.
You just put a fan blowing on the case, probably.
Oh no, I see. What they do is they give you a new top cover that has a hole in it, and they just blow it on the case.
Yeah.
which is thermally bonded to the processor. Okay, so the case becomes the heat sink. Of course, unfortunately, that where that fan is where the pi hat would be. So you just have to extend the pi hat with an extender up higher.
By the way, the piece with that case that is the heat sink says that it really doesn't work. It eventually gets very hot.
Okay.
Oh.
You're reading the comments?
Yeah, down at the comments.
It's just an indication of how much power is being dissipated by the Pi 4 if the case itself is getting hot. So,
Well, and all aluminum does with no air is just take you longer to get hot.
yeah.
And then it slows down anyway.
Keep in mind that at least, I don't know on the Pi, but certainly on the Odroids, I think on the Pi as well, all of the exact throttling points are controlled in, or at least they can be set in software, I believe, and you know, they can be tweaked depending on specific needs. Obviously you don't want to force it to overheat itself, but there's a set of software tools for doing that.
Okay. But you're still limited to how high you can set those thresholds, right?
Yeah.
I wanted to just mention, I noticed some people have left, but we are coming up on half an hour past our time. So
Yeah, let me real quick share this because I don't think everybody's seen this. This is the case.
Well, I got one of those.
So you have one of those, Martin?
Yeah, I just put a Pi in one today.
So what do you think of it?
It works.
Yeah, but that's the one that the comments say that if you let it run and run and run, it eventually gets up to 80 C.
I don't think it works as such a stellar recommendation.
Oh, no. I have a different version.
You bought the one without the fan, right?
Yeah, just a minute. Oh, no, it's a different make. This one. Here's another one. I have another one that has a.
Showing it on the camera?
It has a hole at this end. There's the USB end, and this end is perforated to allow airflow over it.
Is that the same case? Is that a Neo?
No, that's a different. I got another one of those as well. This is by a company called Inoke.
Okay.
Why is that backwards?
It's backwards on yours, but it's right on ours.
Okay, good.
It doesn't say Act 1.
I just put one of those together today to monitor a UPS. I have another question too. Somebody mentioned FFT. Who was that?
That was me.
Who's me?
It was Bill, AB4EJ.
What are you using an FFT for?
Well, that's what we call a snapshotter. It's for people who have very low internet bandwidth. After I collect the IQ data, every 50 seconds or so, I run a 1,000,000 point FFT and then output the CSV file out, and then some. And that is such a low data rate that even if you have a terrible DSL line, you can continuously upload those. That's kind of for a special case.
I put a post in the chat area. Are you familiar with the Widrow LMS algorithm, which is a much better way to compute a DFT?
Nope.
I am aware of it, and I did see your post, and we actually do our the FFTs. The current code that we've been using uses FFTW3.
That's Warren's code, right?
Well, no, that's Warren's DSP code.
But does
which
he
is
use
a
this algorithm in his?
he uses that FFT algorithm, which is a standard one widely used in universities. And Warren's code is really just a rewrite of Bob and Frank's DTTSP. And in fact, it's so closely patterned after it, all the function calls are more or less synonymous.
So what does it do special that DTTSP doesn't? To
He
warrant the
does.
rewrite.
Warren did build a set of channel architecture, but that's and that was really necessary when they went to the Thetis. But it's not used well, it is used in LinHPSDR and programs like that. But essentially it cleaned up the old, if you looked at the old DT, I don't know, Nathaniel, did you work with the old one?
I don't think I did.
It was messy. I tried to write a set of help. There was no comments in the whole thing. And I tried
look at who wrote it. I mean,
well, McGuire and Brickle. So
Brickle, yeah, so they don't need comments.
No. And then Warren, who again was another retired engineer, he sat down and wrote a beautiful, clean, easy to read set of code. And then John Melton took that code, and Warren had done it in C# because Phil got him started on C#. And so John Melton took it and made it where it would work on Android or his Mac or Linux, and it's all straight
So what
C.
did he write it in?
Straight C.
Okay.
He just put a wrapper, he basically took all the functions and took out the stuff that was C# specific.
But how did that relate to this algorithm that Martin was talking about?
Martin's algorithm is a good algorithm, and
Woodrow's.
Yes. Well, it's a very good algorithm, but do we want to be spending our time rewriting FFTs, because we've kind of just been using FFT libraries up to this point?
There are two reasons to consider it. Number one is the biggest problem with FFTs is edge effects.
Yes.
The algorithm assumes that the signal you're looking at is periodic, which is not normally the case. The second problem with FFTs is odd numbers of data points and odd numbers of frequency bins. What if you want 253?
Yeah.
Very difficult to do with an FFT.
Yeah.
Don't do that.
But
we
have been
the processing lag. You got to collect all the points, then you got to do the algorithm, then you get all the frequency stuff, then you got to undo all the bit reversed addressing and everything else. The LMS DFT does it on a sample by sample basis. You bring in a sample, you compute it. You bring in a sample, you compute it. So you don't have any processing delay, you don't have any edge effects, and you could have n number of points in your DFT. That's what I like about it.
Okay, and you're right. The one thing that Warren did is he picked up a lot on Fred Harris's work from San Diego.
Mm-hmm.
And that has a number of clever tools to break the spectrum into pieces and do the overlap save properly. So that if you're doing really big FFTs, and in a lot of what we've done, we have built big FFTs. Some of the projects that we're working on have very small FFTs because there aren't that much bandwidth.
Mm.
So I'm not saying that's good or bad. I'm saying they each have strengths and weaknesses.
Yeah, I know. It's an alternative, put it that way.
But at this point, we weren't planning to rewrite the, unless you want to. Rewrite the libraries.
I have more
Well,
FFTs than you can shake a stick at.
Is that in libraries?
What we're using right now in the radio code that we have existing is we're using for FFT, FFTW3, which is a fairly standard, it's actually a Fortran library originally. It's old.
Yeah, but I'm asking
Well, it was
Martin, are
written
there
mostly by
libraries for this algorithm?
IBM.
Say which?
Are there libraries for this, for the algorithm you're proposing?
No, it's a pretty straightforward algorithm. I have a copy of it somewhere. Libraries in what? What language?
C.
Let's see.
No, I have all the ones I have are in Verilog.
Yeah. See, the thing is our FFTs, except for the filtering, there isn't a huge lot of essentially you're just grabbing a large chunk of data.
All of the HPSDR stuff in the FPGA is done in the time domain.
Right.
So there's no FFTs there. They're in the software.
Yeah.
The PC does them.
Yes.
And I still remember Anna telling me, I don't care what you do in the FPGA, just give me all the data.
Yes.
It's a software defined radio. I write software. Give me the data.
Yes. That's right.
Well, there are a number of cases where that's not what I'm looking for. I'm looking for here's the center frequency I need, and here's the number of samples per second I need,
now,
and put that in a channel.
In that case, you might want to have something like this.
Well, if it comes to me pre-processed, where I know what the samples per second is, I know what the bandwidth, rather the center frequency is, and the samples per second, I don't have to do anything else.
Right.
This FFT is kind of optional. You can turn it off. You don't know. I don't particularly. I use it only in the snapshotter when I want to put out every 50 seconds or so, put out something you can read into Excel, and then you get a few of those out there and use conditional formatting, and you can look at this like a waterfall. It's it's just one way of showing the data. For storing the wide bandwidth stuff, we're not going to run any FFTs on that. I mean, I look at it this way. I mean, what we have now is adequate. What we could do is, as a continuous improvement, we could implement some things later on that would to replace that if we jointly feel like it's important to do so.
Yeah. I think there's nothing we're doing that would limit us doing this other than space in Scotty's VGA, FPGA. But basic
Fred has some really good shortcuts, I want to say, to allow you to do multiple streams. So for instance, like Bill, if you're looking for multiple streams in specific places, that might not be doable. But so for instance, I said, okay, I can give you your choice of 8 of 30 streams, each a megahertz wide. You get to pick 8, any 8 you want, but you can't pick 7.25. You got to pick 6, 7, 8, 9, 10. You get a megahertz wide from 7 to 8, 8 to 9, 9 to 10, because that's what I'm going to filter in the FPGA. You can't adjust them, but you can get the whole megahertz, and then you can tune within it yourself.
Yes.
Well,
so that might be a solution.
That doesn't help me. I've been talking about this for months, and I hope this isn't going to turn out to be a problem. We're going to need 5 to 7 little chunks so we can look at WWV at 5 to 7 different places, and all we need is 8 kilosamples. 8 kilosamples for 4,000 hertz wide.
Okay.
And then for the FT8, we need 4,000 samples per second. And for the Whisper, we need 375 samples per second.
And that's not flexible at all. You can't.
No, those are fixed. It's based
But-
on the decoder.
But you could collect more and throw the rest away.
Right, and actually, you could
That's
divide it-
and that's when you get into the complicated FFT stuff.
Well,
Yeah.
and you could divide it up into sections and then throw the sections away that you're never going to need, and just don't
Well,
calculate. it.
okay, no, okay, but now when you start getting into putting an awful lot of processing load on the Raspberry Pi, which really isn't designed for that. I mean, I thought the FPGA's
no,
strength
I'm
was
not-
to be able
I'm
to
not-
do all that.
I'm not trying to do that, but what I'm trying to do is I'm trying to give you more for your FPGA dollar than you would get if you had just completely independent ones that had all the parameters adjustable, because you're going to run out of space in the FPGA. But if I can take some of Fred's shortcuts and maybe make that fit, you're going to get a lot more data out than you would get otherwise, because his algorithms are much more efficient.
Well, okay, but more data it hurts more than it helps
Well,
for what we're doing here.
Well, ideally, what you would get is, by more data, I mean more streams. So you could take the 8 streams that you want and the widths that you want, and then the other 8 could go to another processor, and the other 8 could go to another processor. And I've already said that I think 6 to 8 is the maximum we're going to get. But with Fred's algorithms, I might get 24.
Yeah.
But they're going to be somewhat limited in what you're going to get. So we got to make sure that the limits we place on them are going to work for you. Otherwise, it's
Okay,
not
well,
gonna-
we may have to have more than one version of the firmware then, because I
I'm
really don't
expecting
want.
it. Yeah, I'm expecting that.
Because remember, like in OpenHPSDR, they were very concerned about real-time availability. But a lot of what we're talking about with the space weather is we want to capture bits of signals and store them. And the processing, the actually use of the signals is later, or could generally will be later in some sort of data analysis. And that's a very different kind of world. And having stuff fast immediately is not nearly as important as collecting everything that you potentially need to be able to solve the problem.
And ideally, what you would do is both. You'd have the specific channels that Bill needs at the rates that he needs, 2 or 3 of them that would take up a larger piece of the FPGA.
Right.
And then you have a general purpose one that says, okay, I can give you slices of a megahertz wherever you want them, or maybe 500 kilohertz, or pick some number. But the fact is, you get all of them to choose from. You can't fit all of them on the wire, but you could fit more. You get more decodes out of the FPGA than you will if everyone has its own set of parameters and they're all different, as opposed to making a bunch of orthogonal channels that just differ in center frequency.
Well, here, all right.
So, but it still fits with our system, and this will be later on when you want more from the FPGA than you're getting.
Yeah, for phase 1, well, here's what we need to be able to do. We need WWV at 2.5, 5, 10, 15, and 20 megahertz. Each one of those is 4 kilohertz wide, with the center frequency at WWV's frequency. Then in addition to that, I need, as many as you can give me, up to 8 FT8 channels at 4 kilo samples per second, and up to 8 whisper frequencies at 375 per sample. But
okay, so that's
all
3.
you got is a grand total of 3 different data rates.
Right, sample rates, right?
Right.
So
3
if I were
different
to
sample
take
rates.
if I were to take the 30 megahertz and say let's pick 375K, that's one of your sample rates, right?
Wait, what?
What's your FT8 sample rate? 375 hertz?
No. FT8 is 4,000 samples per second.
4K.
Whisper is 375 samples per second. Not
Okay.
375,000, 375.
Okay, so pick 375 then. So suppose I take 10 megahertz to 25 megahertz and I divide it up into 375 hertz channels. That's thousands of channels, right?
Yes.
So you only need 8. So I throw away 4,982 channels and give you the 8 that you want. I don't even calculate the ones that you don't want.
Yeah.
Right.
So I only use the space in the FPGA to calculate streams that you want. So, and I think that's doable. And then however many other 375 hertz channels you want, tell me the center frequency, you can get them. Well, let me put that a different way. You get the center frequencies that I say, so I have to pick the center frequencies so that you get 10, 15, 20, all the frequencies that you want.
Well, is it going to be a problem for us to simultaneously run 5 WWV channels and 8 FT8 channels and 8 whisper channels?
I don't know. I haven't written the code yet.
I don't perceive that as a problem.
But when you start talking about everyone has its own independent sample rate,
right?
And everyone has its own independent filter
stop.
width.
Hang on a second. I never said that.
Okay, but you said 3 different ones.
Yes, that's right. You don't. It's not that everyone has its own. There are 3.
Right.
There are 3 sample rates.
But at any rate, the normal way you would do it is you'd have basically a separate virtual receiver for each stream. And to do that,
so,
I mean, it doesn't matter if it's a different sample rate. You have, obviously you'd have a narrow filter for the 375 one and a wider filter for the 4 kilohertz kilosample one. But other than that, you would have multiple 4K sample ones. You have multiple 375 hertz ones.
Right.
But all I'm saying is that if you want multiple of one particular sample rate, I might be able to give you more of them if you let me pick the frequency, center frequencies.
Well, as long as we can get the ARRL and everybody else to go along with having whisper and FT8 on different frequencies.
No. But okay, so FT8 is going to be on 14070, right? Or some such thing.
Yeah,
right?
I mean FT8 at 14.074, I think, and there's fixed frequencies.
Okay, but suppose that I gave you and you want it centered on that frequency, right? So you want
no. Well, actually, what it is, well, I guess I must say I'm not sure. The way you set your receiver up to pick up one of those is 14.074 is the dial frequency.
Right.
Then you put the rig on upper sideband, and then you've got between about 400 hertz above that and about 2,800 hertz above that becomes your actual FT8 band.
So where would you want the center frequency at? And this is FT8, so it's 370. No, it's 4K samples per second, right?
Right.
So
where do you
really what he wants is a bit of spectrum.
Right. But all I'm saying is, okay, so say you asked me for 14075 and you want 4K samples. So you want 2K on either side. Suppose I tell you that I can only give you 14070 center frequency. Can't you deal with that? You're going to get the whole spectrum anyway. Is that too hard to move your center frequency off of the exact 0 point in the middle?
I would have to say I don't know, because this is a question that just came up for the first time.
Yeah.
I don't know. I really don't want to have to do signal processing on the Raspberry Pi. I mean, because that's what's going to kill us.
But I don't want you to. I'm just asking because it might lend for an easy optimization inside the FPGA if it doesn't break your end.
Right.
Well, that's all I'm thinking.
I guess I think we may need a couple hour session to work on just that one question then, because we have to, how you do it when you are working with an amateur receiver, a typical one off the shelf, and how you do it in using this system that we're designing now may be different.
But it just seems that FT8 signals, there is a band of them anyway, because not everyone operates on the same frequency, right? Because the radios shift frequency.
Yeah.
So therefore you're going to be offset anyway. The question is, can you offset a macroscopic amount versus the small signal amount that the FT8 channels are really narrow because they're only a few hertz wide, like 6 hertz wide or something. So
I guess really to answer this, maybe what we're going to need to do is we're going to go back and reverse engineer how it's being done in Pavel Demon's FPGA on the Red Pitaya.
Right.
We have the code for that if you want to take a look at it and see how he does it.
Okay. Do you know whether you have a link to his GitHub or something where we could get that?
Yes.
Yeah, sure.
So here's something Martin and I can look at.
What's that?
Because he runs. He
Looking
can
at the
run.
FPGA code for the red Pitaya.
It's on the GitHub. It's on his. It's on. And bear in mind now, there's two different. Well,
See, this is why I asked for the GitHub address, because I'm not a GitHub user, and you say, oh, it's on GitHub, you can find it, and I go and look, and I can't find crap. So I'm not very good at that. So I need a little more direct pointer.
I don't know that I can necessarily find it on a while you wait.
Well, okay, so
here you go. Just a second.
Okay.
I got to find my window back here. I had it highlighted. Let me get it there. Copy. Here we go.
There's an FFT for you.
What? That doesn't want to paste in the chat, does it?
Can you paste it to everyone?
Yeah, I'm trying to. To everyone.
Martin, I went to that Google Drive link you put in there. It won't let me in.
The won't?
It says you need access.
What, the one I just put on the...
Yes.
No, it's told me that... Get a link. Oh, yeah.
All right, I found it. There
Okay,
it is.
keep
There's
updated
the
the permissions.
GitHub. That red Pitaya notes.
Yep.
It's in the chat.
Okay.
Yeah, that was the one I was trying to paste.
Yeah, it took me a couple of goes at it. If you look at under cores, I believe.
So he provides FPGA code, but it's for Xilinx.
Right.
Well, that's okay. We can read. If it's Verilog or VHDL, we can read it.
So Red Battalion uses a Xilinx and a SoC.
Yeah, I have gone in and looked at this.
It's Verilog.
Oh, good.
I
VHDL
realized
is a behavioral modeling language.
Yeah.
Guys, I need to go. I can't stay.
Well, we
much
got
longer.
kind of off the subject here, and I don't want to throw a wrench into your what you're doing there, Bill, because everything is going to be useful. It's just that I'm already looking for optimizations, because I think the demands on the FPGA are going to get greater and greater and greater, and we're going to either end up with multiple loads to do different things, or we're going to have to try to find a way to optimize it. And Fred's algorithms are pretty cool if they could be optimized and they would work for us.
Yes.
Maybe they won't.
But again, there are different capabilities, and changing the computer that we hook to the uses a local host. We're going to have standard ones, but I expect that there will be some problems we'll need a bigger computer, and other problems we can use the small one.
And so it may be that we can only run 4 to 6 channels on the FPGA that we have now without the optimizations. And then the optimizations will require a heftier local host. So we might be able to get 16 channels then, but you'll still need an i7 to decode it, not a single board computer. So it's just a system trade-off.
Yeah.
And we can make that trade-off. Right now, the focus on the personal space weather station is not the i7 version. It's the small localhost version.
Yes.
Yeah, I mean, if you want to run everything simultaneously, obviously you're going to bump your head on the ceiling pretty quickly with the Raspberry Pi. You have a little bit more headroom on an Odroid.
We still could try an NVIDIA board.
Yeah.
They aren't that much more.
Well, we could just see where we run into bump our head on the FPGA, because that's going to be the case where you want to try these these fancy things to reduce the size of the code in the FPGA.
Yep.
Yeah,
And the
right
other
now we
alter-
don't know where the bottleneck is going to be.
We don't. Not until we get things out the door.
Yep. Guys, I need to go.
I do
73.
too.
Yeah, I do too. So
All right.
Johnny,
Good
are we
session.
meeting
good.
on
Learned a
Wednesday?
lot.
yeah, I'll see you on
73.
Wednesday. Yeah.
Wednesday?
I'll see you, Martin, on Wednesday at
Sounds
5.
good.
7-3s, everyone.
7-3.
Hey, everybody.
73.